So in this case, I'm going to be doing a flow proof. It's acceptable to do a two-column proof or another kind of proof, but I'm going to choose to do a flow proof. And let me do this, inside white. Eventually, the thing I want to show is going to be the very last thing on this page. And so I'm going to go ahead and fill that part in. Segment AE is congruent to segment BB. Well, the only way I could show that this segment is congruent to this segment is if I know that I have congruent triangles and I use CPCTC. The only way to use CPCTC is to have two congruent triangles before that, because CPCTC stands for corresponding parts of congruent triangles are congruent. So the only way I can say that these parts are congruent is if I know the triangles are congruent. So I'm going to have to say triangle something is congruent to triangle something else, and then I'll have to use side, 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 angle, side, etc. One of those things to get me there. And then again, before that, in order to prove that two triangles are congruent, I have to have three sets of parts that are congruent. Three angle pairs, three side pairs, and in certain configurations to make that possible. So somewhere, these three things are going to lead together into me being able to say that the triangles are congruent for some reason, and then I can say that the corresponding parts are congruent. Well, I know based on what they have me finding that side AE has to be one of the sides of the triangles that I'm proving congruence for. Looking at the original givens, angle CDB is congruent to angle CEA. So here's angle CEA from the triangle that I'm just starting to outline. If I need to set that angle in place, it means that this side that forms these two sides that form that angle have to be two sides of my triangle, which means this is one of the triangles I'm working with, triangle ACE. So over here, I'm going to have triangle ACE congruent to triangle BCD. I don't know why yet, but I know if those two triangles are congruent, then I can say these two sides are congruent. They also gave me that segment CD is congruent to segment CE. So I've got an angle and I've got a side. I need to find either that this longer side here is congruent to this longer side here, and I don't see anything that's going to let me do that. Angle A is congruent to angle B. I don't see anything that would let me do that. But what I do notice is that angle C is shared by both triangles. It obviously has to be congruent to itself. This is going to give me an angle, side, angle congruence. Now, the three things that let me use that angle, side, angle congruence were that angle CDB is congruent to angle CEA. The reason I know that is because it's given. That side CD is congruent to side CE. Again, I know that because it's given. And the other angle I used up here was that angle C in the one triangle is congruent to angle C in the other triangle, and the reason I can say that is because it's the same angle. These three things let me say the triangles are congruent, and because the triangles are congruent, I know the corresponding parts of those triangles are congruent.